All right, so let's take a look at example, this first one here. So we're going to use Desmos to fully graph the parabola, which has the vertex at 10, -4 and contains 8, 4. And so I'm going to pull up Desmos here, and we're going to go through how we do this. And I'm just going to have to put this into the corner there. I'm just going to bring back to home. Now, the first thing that we're going to do is we're going to make a table. So if you go to the top left here, you'll notice that we have a little plus sign. We're going to make a table, and this table is going to have x1 and y1, and then it's going to plot the points on the graph. So the first one is 10, -4, and then we also have one at 8, 4. And I'm just going to pull this out here. All right, these are 2 points. There's 8, 4, and here's 10, -4. We know that this is the vertex. So we have a vertex down here, and then it's going to be going up. This is our minimum value, and it's going to be going up. Now, like I said previously, we need 3 points. Okay, so you have to have 3 points to be able to make this. So we're going to need a third point, but we're not actually given that point. Now, let's remember that every single parabola is symmetrical. Okay, and so I'm just going to quickly draw this on here a little bit. So this is what our graph is going to look like right here. You know, Desmos is going to do that. Okay, that's what our graph is going to look like. It's going to be symmetrical around this line right here. That's kind of cool, isn't it? X equals 10. And so if we have something at 8, 4, which is 2 spaces away from 10, we have to have the same point here at 12, 4. So what we can do, and I'm just going to quickly see if we can erase that because we don't need that anymore. What we're going to do then is we know that the other point that we have to have is here at 12, 4. Okay, so we can add 12, 4 to there as well because we know that it has to be symmetrical. So whatever's on this side has to also be on this side. Okay, so that's how we can understand that something is symmetrical. All right, now we have our 3 points. These ones just happen to really give us a good look as to what our quadratic should look like. And now we're going to put our regression in. So we click a new tab here. And what we're going to be doing is collecting from the previous table. And so that table includes x1 and y1. So we have to put in our regression based on x1 and y1. And I suggest, and you'll get your teachers next year in grade 12 will suggest the same thing, that you always start a new table. Okay, so always start a new one, always do a new table. Always do something fresh because otherwise it gets a little bit finicky and we don't need to go through all those problems right away. So let's start this new table here, or this new one. And so what we're going to do is we're going to access y1. And so if you type in y1 into Desmos, it's going to recognize that you're pulling from this value right here. And then we're going to put in a little twiddle sign. And so you'll notice that little twiddle sign there. That is the key right beside the number 1 on your keyboard. You're going to have to hit shift and then that key. It's what's called a twiddle, so it's a little kind of squiggle. If you want to do a squiggle, maybe that's a better word for it. It's called a twiddle sign as well. That's instead of our equal sign. So we're going to do that. And then we're going to type in the rest of our regression. It's going to look kind of like a formula, except with no numbers in there. So we're going to do x1 squared, and you can really just type that in, x1 and then to the power of 2. And you'll see stuff start to kind of form up on the screen. Don't worry, we're going to get to that yet. And then we're going to do plus bx1 plus c. And when you type that in, what it's doing is it's asking Desmos to take those 3 points that we have. Okay, so take these 3 points right here and try to figure out what quadratic best fits those 3 points. Is there a quadratic that can fit in those 3 points perfectly? Okay, and in fact, yeah, we got one that looks pretty much perfect. It goes through all 3 points. You'll notice this is a nice parabola right here. Okay, that goes through the point 8, 4, the point 12, 4, which is right there, as well as has a vertex at 10, -4. Okay, so that comes up with a very nice parabola right there. It's opening up, and it's in fact, quite narrow compared to what parabolas may look like. Now, we want to kind of figure out what is the equation that goes along with that, and that's the important part. Just having this parabola, it's cool, nice, helps, but we want to kind of come up with exactly what is the equation that represents this. And so what we're going to do is look at what are our A, B, and C values, and that's right here. So instead of having just A, you have 2. Instead of having B, it's -40. And instead of having C, it's going to be 196. Okay, and I'm going to be starting a brand new video because I have a maximum here with how that exactly looks.